Hey, this is screencast 3.6 for AP Chemistry. This is about net ionic equations when you have a weak electrolyte. We taught before that in general, if you're coming up with a net ionic equation, you can simply look for the precipitate of the reaction and show the ions that form it. And we say in general because you can get in a little bit of trouble if you just try to whip that out and think that that's always true. And here's a case where it's not. Let's write molecular ionic and net ionic equations when we're reacting hydrogen cyanide with sodium hydroxide in water. So let's write the molecular equation first. That means write the whole double replacement reaction. So hydrogen cyanide will react with sodium hydroxide to make sodium cyanide and water. They say it's in water, but note that water is not serving as a reactant, so we can leave it out. Note that we always attach the cation to the anion. These are always plus minus, so sodium plus, Cn minus, H plus, OH minus, which is water. When water forms, it's a liquid, so we write it as such. When HCN is in solution, it's aqueous. When sodium hydroxide is in solution, it's aqueous. All these things are true, but if you're writing the ionic equation, let's consider what's really in the flask, right? And the big thing here is that HCN dissociates very little, so we're simply going to keep it together. That's the rule with the weak acids. If they only dissociate a little bit, we're not going to write the ions, since by and large, you don't see the ions. Obviously, they had to make an approximation there, but that's the one they chose to make. Okay, so we're going to write that together as HCN aqueous. But in solution, this thing's completely ionized, so we're going to show it as such, as is this. This is a liquid, so we write it as such. So let's break it down. Notice that we did not break down HCN since it's only a weak acid. We did break down everything else, and we don't break down water because it's in the liquid form. Now let's just remove the spectator ions. There's not that many. In fact, is it just sodium? It looks like it is, so the net ionic equation looks like that. Now you can do it this way, or if you're an AP student, you get to do this enough. Just keep the weak acids and the weak bases together. Just don't break them apart, and you might save yourself a little time. But writing out the ionic equation and canceling the spectator ions is always a good idea as well. So that's neutralization reactions when you have a weak electrolyte. Remember to keep those together.